Alright, so we have a circuits problem here. So there's a battery with an EMF of 72 volts, and we got a resistor R1, right, and it's going to be hooked up to a resistor R2, which has a resistance of 2 ohms. We have 2 capacitors as well connected, which are in parallel. We have one with 3 microfarads and one with 6 microfarads of capacitance. And all the capacitors are fully charged. And the charge on C1 is 18 microcoulombs. So we need to find out what is the charge on C2, and then what is the resistance of R1. So go ahead, pause. Did you pause? Did you try it? Hopefully you tried it. What was I going to say? Oh yeah, let's just start. Charge on C2. Hopefully this one's not too bad because we know they're in parallel. How do we know they're in parallel? Well, they're connected to the same point right here, right? So all the charge here has a choice of going here or here. So if this is the case, right, they're going to have the same electric potential difference, right? So the voltage here is equal to the voltage here. What we can do is we can kind of say, hey, the capacitance C1 is going to equal Q1 over V. So and then we can multiply this by V. Oh, and the reason we're finding what the V is because if we want to find the charge on C2, we're saying, hey, C2 is equal to Q2 over V. I don't know what V is, but guess what? They have the same voltage. So we can say C1 is equal to Q1 V1, or V is going to equal Q1 over C1. So that would be 18, so we would have V is equal to 18, let me give myself some space here. We have V is equal to 18 microcoulombs over 3 microfarads. Remember, the micro sort of prefix just tells us like 18 times 10 to the negative 6, so the micros kind of cancel out essentially, and you get 6 volts. So it's not microvolts, it's just volts. So if the voltage is 6 volts, then we could say, okay, well, I need to find Q2, so V times C2 is going to equal Q2. And this just comes straight from the capacitance ratio equation on your equation sheet. So V times C2, so we have 6 volts times C2, which was 6 microfarads. We would get Q2 is going to equal 36 microcoulombs. And remember, right, micros to 10 to the negative 6. So 6 times 6, then you multiply by 10 to the negative 6, you get microcoulombs. Okay, cool. That was pretty straightforward. 36 microcoulombs. All right. So the resistance of R1. Hopefully, when you're thinking about solving resistance, and you're given an EMF and some sort of voltage, you think of V equals IR, Ohm's law, right? So I'll make some space right here. V equals IR. Now we want to know we really want to find the resistance of R1, and we don't really know the voltage it faces, right? Because it's not 72 volts, because some of the voltage goes here, and then some of the voltage goes for these 3. So it's not 72 volts entirely, and also we don't know the current. What we can do is kind of realize that, hey, when these are fully charged, there's no more current going to them, right? Because when they're fully charged, all the current is going to be like, oh, wait, these are fully charged. There's no space for me. Let me just redirect myself to the resistor. So when these are fully charged, they essentially make no difference to the circuit as if we were to take them away. All the current would just be channeled through this sort of section here. So in that case, we have a resistor in series, and the equivalent resistor is going to equal R1 plus R2, right, for a series. So we would say the EMF in this case is going to equal I times R1 plus R2. Okay, so we know the EMF, great. We know R2, great, but we don't know the current. Well, what you can do is use R2 in this case. So for R2, we know that, okay, so we can kind of do this. V2 is going to equal I times R2. Now, what is V2? What is the voltage that is going through this resistor? Well, remember, all three of these are in parallel. So whatever voltage these two face, it's also going to experience the same voltage because it's hooked up to that same point right there, and it's going to experience the same potential difference. And we found that the V is 6 volts. So we could say 6 volts is equal to I, which is what we're solving for, times 2 ohms, which is given. All right, 6 volts, 2 ohms, so 6 divided by 2 would be 3 amps, right? So 3 amps, 3 amperes of current. And now what we can do is we can plug that back into here. So we can say EMF is equal to I, so let's just, honestly, we can just take this equation now and just plug everything in. So we can say EMF, I'm going to kneel down here, we have 72 volts is going to equal 3 amps times R1 plus R2, which is 2 ohms. And now we have everything to solve for R1. So 72 volts divided by 3 amps is, I can do the, you have a calculator, but I'm just going to do it here. So we have that goes in 2 times, should be 24, right? Yeah, it's 24, and you can verify that with your calculator. So we can say 24 ohms is going to equal R1 plus 2 ohms, and R1 should therefore equal 22 ohms of resistance. All right, so there you go. Those are that's the answer. Yeah, hopefully that made sense in the process. And I know my hair is like cooked. I'm getting actually a haircut today. So yeah, bye. Thank you.